The nice thing about similarity in triangles is we don't have to have all three angles and all three sides. We can have just pieces of them. In fact, there's 3 tests for similar triangles. The first one is angle-angle similarity. It says if 2 angles of one triangle are congruent to 2 angles of another triangle, then the triangles are similar. If you look at the 2 triangles that are up here, you see that they've given me that angle P is congruent to angle X. They've given me that angle R is congruent to angle Y. And since they've given me these 2 pieces, I know that triangle PQR is similar to, again, the order of this first one would not matter, but the order of the second one does, X, Z, Y. And the reason that this would be true is angle-angle similarity. Remember when we were doing congruent triangles, we said you could do side, 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 angle, side. Well, when you're dealing with similarity, it's kind of the same thing. But in this case, if you have 2 angles congruent, then I can show that the 2 triangles are in fact similar. Questions on our first method? The second method is like congruency where we had side, side, side. It is side, side, side similarity. It says if the measures of the corresponding sides of 2 triangles are proportional, the triangles are similar. In other words, I don't have to know about the angles. I can prove that the 2 triangles are similar if I can show that the 3 sets of sides, in fact, are proportional. If I take the smallest side, 6, and I compare it to the smallest side in the other triangle, 2. It should be equal to the medium-sized, 8. And rather than working with this as a mixed number, I'm going to work with this as an improper fraction. And then the largest side would be 12 over 4. How many times does 2 go into 6? 3. How many times does 4 go into 12? 3. So if I take 8 and I was dividing it by 8/3, what's our rule when we're dividing by a fraction? Keep, change, and flip. What's going to happen to the 8s? They cancel out, and obviously then this is also equal to what? 3. Since the 3 sets of sides are proportional, triangle ABC is similar to triangle DEF by side, side, side similarity. By the way, once I know that these 2 triangles are similar, what can you tell me about angle A and angle C, angle D? They're congruent. Angle B would be the same as angle E, angle C would be the same as angle F. Because if 2 triangles are similar, then their angles have to be equal. The last rule is side-angle-side similarity. Notice the angle is caught in between the 2 sides, and notice we use that phrase again, included angle. It says if the measure of 2 sides of a triangle are proportional, to two sides of another triangle, and the included angles are congruent. Notice, M is congruent to O. They've given me that. So if I can compare 10 to 5, and I can compare 8 to 4, if these are in fact proportional, then these two triangles are similar. Well, 5 goes into 10 twice, 4 goes into 8 twice, so these two sets of corresponding sides were proportional. Triangle LMN is similar to triangle QOP by side angle side similarity. Everybody good so far? Some of your problems today, they're simply going to ask you, can you determine if there's enough information to state that the two triangles are similar, and what postulate did you use? In other words, did you use side, 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 angle, side? What did you use? What do these two symbols mean in example 1? That these lines are parallel. What can you tell me about this angle and this angle? Why?
The shorter angle is twice as...
These two angles are congruent. Why? They are corresponding. How about this angle and this angle? They're congruent too because they're what? Corresponding. So if I look at triangle GFH, it is similar to the big triangle GEI by what postulate or theorem? Angle, angle, similarity. There's more than one way to do example 2, but to me the easiest way, what type of triangle is triangle ABE? Look at ABE, what type of triangle is it? What does it tell us about the base angles? So I'm going to mark these two as being congruent. And I know that these are congruent because it's isosceles. What about this angle then over here? Why are these two angles congruent? They're vertical. What type of triangle is triangle CDE? It's also isosceles, so I can mark that angle as being the same because these are base angles. So are the two triangles similar? They are in fact similar. Triangle BAE is similar to triangle DCE by angle, angle, similarity. You could have also done side angle side similarity because these two angles are vertical. And you could have done 21 over 35 and 27 over 45 and found that they were proportional. Pretty good? Okay. In example 5, they did not mark these two angles as being congruent, so let's mark them. Otherwise, there really isn't enough information in example 5 to do the problem. For each pair of similar triangles, find the value of x. If I know that this angle is congruent, I know that these two are congruent because they're vertical, so it does kind of tell me where everything lines up. Between 1 mark and 2 marks, So I'm going to compare 2x plus 10 to x plus 3. Between the 1 mark and 0 mark, 10 is going to compare to 4. And there's my proportion, and we would cross multiply to solve this. 4 times 2x, 8x. 4 times 10, 40. 10 times x, 10x. 10 times 3, 30. Subtracting 8x from both sides. 40 is equal to 2x plus 30. Subtracting 30. 2x is equal to 10. And dividing by 2, x is equal to 5. Be careful when you're doing a problem like example 6. The two triangles that are actually similar here, and let's go ahead and mark this side as being parallel because otherwise, again, there's not really enough information. Really, what I'm comparing is the little triangle, which has the 6 and the 5 in it. And I'm comparing it to this great big triangle. And again, this would be 6 plus 3 3/5, which would be 9 3/5. And this would be 5 plus x. I certainly don't want to work with 9 3/5. I'd rather work with it as an improper fraction. 9 times 5 is 45, plus 3 is 48. So 6 compares to 48 over 5. The same way as 5 would compare to 5 plus x. And we would cross multiply to solve this. 6 times 5, 30. 6 times x, 6x. What's going to happen when I multiply 48/5 times 5? 5s are going to cancel out, just leaving me the 48. Subtract 30 from both sides. 6x is equal to 18. Divide by 6, x is equal to 3. Questions?
How do you figure out like which numbers go on something, like the quality?
How did I start with this 6?
Yeah.
Didn't matter where I started.
So you could
It just matters that if I do 6, that what goes underneath it? The 48 over 5. And even if it didn't go underneath it, I could have put it across from it, It just matters that if I'm starting in one triangle here, that I either make the comparison here in the triangle of the same thing, or I make it here. It can't be on the diagonal. Okay? Corresponding sides have to be lined up one way or the other. Okay. There's your assignment. Remember, you're going to have to use the quadratic formula on these two problems. When you're using the quadratic formula, it needs to be in this form. And the quadratic formula says negative b plus or minus the square root of b squared minus 4ac all over 2a.